Okay guys, so I wanted to walk through this problem because a ton of people were asking me questions about it after the review session. So this problem tells us that sodium hydride has a pKa of about 35 or 36, which, as we know, the higher the pKa, the more basic it is. So that means NaH is like pretty basic. And alcohols have a pKa of about 16 to 18. So if you think like water, ethanol, methanol, they're all going to be in that range. So with that information and our chapter 7, chapter 8 knowledge, we're going to try to predict the product of this reaction. So what this information up here really tells us, the fact that sodium hydride has a pKa of 35 to 36, so about 36, and alcohols have a pKa of about 18. No, 36 is a lot bigger than 18. It's about 18 pKa units away, and we know that anything more than 10 is like considered a really large pKa difference. So that means that what we're going to see happening when NaH and any ROH, so any alcohols, are in solution, we're going to get an acid-base reaction going on where that sodium hydride takes the proton from the alcohol. So we get RO minus, H2, and Na plus in solution. Okay, so now that we know that, we can apply it to our problem. What we see first here is that we've got an OH and we have an NaH. And like we just said, when we have an NaH and any type of alcohol, we're going to get that acid-base reaction going on. So our very first step in solution, this is going to happen pretty instantaneously, is that NaH is going to go ahead and deprotonate the alcohol. And we draw this with irreversible arrows because, again, that pKa difference is just so large. So once we do that, we get an intermediate that looks like this. Now, one thing you might notice about this intermediate is that it has a O minus, which, as we know from chapter 7, is a good nucleophile and a good base. It also has a good leaving group here in the bromine, and that leaving group is on a primary carbon. So I'll write all that down here. O minus is a good nucleophile and base. Bromine, good leaving group, and that's on a primary carbon. Now, altogether, what does that indicate to us? It indicates that we're going to see an SN2 reaction happening here. So, since this is the only compound in solution, we're going to see an intramolecular reaction happening here. What that's going to look like is that this oxygen is going to attack at the primary carbon, and that leaving group, the bromine, is going to leave. So, what this forms here is this oxygen right here forms a bond directly to that carbon that the bromine used to be on. So that means we form a cyclic ether. Now what that's going to look like is a 6-membered ring, and oxygen is part of that ring. Let's go ahead and number our carbons so you can see what that looks like. If our first carbon is right here, the one that's originally attached to the oxygen, we can count that as there. Then 2, 3, and 4 are all kind of in the middle. And that 5th carbon right there that used to be attached to the bromine is now also attached to the alcohol instead of the bromine. This is where we get our substitution reaction coming in. So, okay, I hope that was helpful. Please email me if you have any more questions, and good luck studying for your exam tomorrow.